Okay, in this lecture we are going to learn what is electrochemical series, the arrangement of metals, in decreasing order of tendency to lose electrons. That means metals are arranged in this way that in the decreasing order of losing electron. This is known as electrochemical series. So the series in which the elements are arranged on the basis of values of electrode, so just leave it. So only learn up to electrochemical series. So only learn up to electrochemical series. Okay. The arrangement of metals in the decreasing order of tendency. Okay. So now next, this is the series you can see over here: lithium, potassium, calcium, sodium, magnesium, in this way. And if you see their electrode potential minus 3.05, that means it has very less potential. Okay, and as we go down in the series, it gets the positive values. That means electrode potential is increasing downwards. Clear? Okay, increasing downwards. Then you can see here positive, and here it is 0 0. That means it is for the case of the hydrogen. Okay, so you have to remember this series if possible. Lithium, potassium, calcium. You can see over here lithium, potassium, first group, then calcium, then sodium again first group, then magnesium second group. So you can see that according to the group periodic table we can arrange them. And the third group, aluminum. Okay, clear? So there's a little bit up and downs, but you can learn it. Okay, and in the hydrogen comes after 10 and before copper. So now copper is below the hydrogen. Clear? And now from the copper the electrode potential get positive values. Clear? So now silver, these are okay. Now you can see that there are some things written: increasing tendency for reduction. That means increasing tendency to accept the electrons. Clear? So these are the oxidizing agent, here the reducing agent. So these are different things, and we learn these one by one. Now what is the definition? The arrangement of elements in increasing order of their electrode potential. We can also say that. That means we arrange all the metals in order of their increasing electrode potential, because on the top we have less electrode potential and in the bottom we have more electrode potential. So this definition is very easy to remember. The arrangement of elements in increasing order of their electrode potential is called electrochemical series. Now how this series is useful for us? Why this series is useful for us? Number one, and comparing the reactivity of metals. So be careful now here in these sentences, because lot of questions are from these application of electrochemical series and mathematical type and conceptual based questions. These are asked in your examination. So be careful for this video. A metal with lower SRP have ability to displace metal with higher SRP. Listen. Secondly, the reactivity of metals decrease from top to bottom. That means the metals which are at the top, they are more reactive. For example, in this series, if you can see, we all know that potassium is more reactive in comparison to copper. That means the elements which are at the top, they are more reactive, and the elements which are in the bottom, they are less reactive. That means reactivity decreases. Reactivity decreases. Okay. So now metals higher in the series are more active, and the metals lying in the lower in the series are less reactive. Okay. Moreover, the elements which are placed above hydrogen, they have ability to displace hydrogen. So when the metals which are placed above hydrogen, when they react with them, they have ability to produce hydrogen gas. Clear? Now next topic, in comparing oxidizing and reducing property. So be attentive for that. It is a very confusing topic. Oxidizing nature increases from top to bottom and reducing behavior decreases in the same way. That means oxidizing nature increases. You will learn only one thing, either oxidizing, either reducing, and make the inverse of that. Firstly, in the first point, we learn reactivity decreases. We learn reactivity decreases, R for reactivity. Okay. Similarly, in the second one, we can see that reducing decreases. So this is again from R. So reducing decreases. So when reducing decreases, oxidizing increases. So you just take the R. So when we move in electrochemical series, reactivity decreases, reducing power decreases. So now it's easy. Okay, so be careful and please note my language, my words here, that reducing property decreases when we move in electrochemical series and reactivity decreases when we move in electrochemical series. Now in the calculation of EMF, now how can we find the EMF? We just subtract the two electrode potentials which are given in the series and we get the electrode potential, EMF, the value of EMF of the cell. Now in predicting the feasibility of the reaction, feasibility of reaction means whether the reaction will happen or not. Okay, whether the reaction will happen or not. In other words, see over here, in other words, 1, 2, 3, 4th line. In other words, we can say that for a reaction to occur, it is necessary that the species with greater tendency to lose electron loses its electron which is gained by the species which have greater tendency to gain electron. So it is not clear over here. Similarly, for a reaction to occur, it is necessary that a species with greater tendency to lose electron loses its electron which is gained by the species with greater tendency to gain electron. So it is just useless, just go to another one, it's not clear. But here we can say that the metal which was before it, okay. For example, in a reaction, I will take one more example. For example, we have a reaction that means K2SO4 and when it reacts with copper, okay, then copper cannot displace the potassium. But if we have copper sulfate and it reacts with potassium, then we can form potassium sulfate. Okay, that means if the metal which was above in the series, it comes in contact, the reaction will happen. And clear or not? No. For example, we have a reaction. I will take a space over here. Wait. Listen, we have a space over here. See, for example, we have a reaction like this. Copper sulfate and the metal potassium came in contact. Okay, then reaction with fissile, K2SO4 is formed. Okay, and copper is reduced because potassium is more reactive than copper, because potassium comes on the top of the electrochemical series. But for example, we have K2SO4 and copper came in contact. Copper is in the downward position. Clear? So it is less reactive. So no reaction. Clear or not? We have a compound and there's a metal which came over here which is more reactive. For example, I have an idea. You have a friendship with someone. A person came who is very jolly, who is very impressive. Your friend gets attracted with him and your friendship will break. And for example, you have a friend and a person came over there who is not so attractive and your friendship will not break. Clear? If the substance which came in contact is more reactive, then the reaction is feasible. I think it's clear to you now. Okay? So this is known as feasibility of the reaction. Understand? Now it's not useless. Now in protecting the metals from the corrosion, it is done through